All right, so this is a nice relaxing video. We've already done all the hard stuff here, okay? And in fact, we've already done common logs. We just didn't call them that. So we'll start with the definition. Jason, you forgot to write the base of the logarithm. Oh no, I didn't. If we don't write the base, this is what's known as the common log, and it just means log base 10. Right? We've done this before with square roots, right? Square roots technically have a 2 here, but because we use them so much, we just stopped writing it. It's the same with the common log. If you don't see a base, that means base 10. All right? And this is known as the common log. Now, similarly, if we write ln of x, this just means log base e. The number e, Euler's number e, pops up in a lot of natural applications for population growth and stuff like that. So it is the natural logarithm. You may have seen these before. If you remember them, good for you. If you're seeing these for the first time, that's fine too. All right, and your calculator has buttons for the logarithm, the common log, and the natural log. Your calculator will not have buttons for log base 2, although your computer can, but your calculator will have these buttons, natural log and common log. Okay, so let's just use them a bit, but nothing new. Nothing new in example 4. Evaluate the following using a calculator if necessary. Again, you can do all of these with a calculator, but it's really a good idea to do them by hand where you can. It'll give you conceptual reinforcement and a stronger grasp of the material, because some problems are going to have variables and you won't be able to use a calculator. So it's good practice for those more complicated problems to do it now. And where applicable, round to the nearest 10,000th. Now, if you're anything like me, and you're probably like me in some aspects, you might not immediately know what this means, 10,000th. So you can just like kind of count for decimals, right? This is the 10th, and then 100th, and then 1000th, and then 10,000ths. Okay, so it's really asking us to go to the 4 decimal places. So don't hesitate to just do that little logic on the side if you're ever curious. All right, so that's what it's really asking, round to 4 decimal places. All right, let's do it. Part A, the common log of 1,000. Or you could just say the log of 1,000. All right, well, we can do this exactly like we did it in the last video. And if you want, you can write a little 10 right here and say, we want to know what this equals. So we can think about it like this. And then just like before, we can say the base of the logarithms, the base of the exponential function. So 10 raised to what power is going to give us 10,000? Well, 10 to the first power is 10. 10 squared is 100. Okay, 10 cubed is 1,000. So that's our answer. 10 raised to what power gives us 1,000? 10 raised to the 3rd power. And if you type this in, the common log of 1,000 into a calculator, common log of 1,000 should also give you 3. Excellent. Calculator is backing me up today. Always a good sign. All right. Let's do some more. Part B. Common log of 1 over 100. In fact, I'm going to write down a bunch of problems. I would recommend pausing the video, trying to just do these on your own, okay? I think you can. I think you're capable. common log of 1 over 100, common log of 102, common log, the natural log of the square root of e, and the natural log of e cubed. Pause the video now. So, just like before, this is 10 raised to what power is going to give us 1 over 100? -2. It's negative because it's reciprocal. 1 divided by 100. Okay, and you check it with your calculator, right? Check this with your calculator, it should give you 1 over 100. 10 raised to what exponent is going to give us 102? Nothing. Well, that's not true. Not an integer. There's a number. It's just going to be an irrational number. 10 raised to what power is equal to 102? Look at that. 10 raised to what power looks like this. When does that equal 102? When does that equal 102? Right there. At about 2.009. Or, this is where we have to use a calculator. What is log base 10 of 102? About 2.0086. It's approximately 2.0086. Now, we know the answer is close to 2, even before typing this into a calculator. Side note. What would this be close to? This would be close to 3. Because 10 cubed is 1,000. Right? So 1,050 is going to have an exponent that's really similar to that 3. 10 squared is 100. So we're just a little bit more than that. Okay? You can kind of use that logic and have an expectation for some of these ones that you have to approximate. All right, letter D, go off to the side. And remember, all right, remember this one. This is saying log base e of the square root of e equals some number that we're trying to find. So to convert that into exponential notation, that's e raised to what exponent gives us the square root of e. What kind of exponent turns into a square root? An exponent of 1/2. The natural log of the square root, SQRT in Desmos, of e is 1/2. Just like so. Do the same logic with part E. That's part E. Ha ha ha. Log base e of e cubed is some number that we're trying to find. So convert this into exponential form. E raised to what number gives us e cubed? Well, I guess that number has to be 3. And again, you can check with a calculator. Let's do 2 more. Part F. 2 times the natural log of 10 plus 5. Again, we're just going to go off to the side and say, let's figure out what the natural log of 10 is and then multiply it by 2 and add 5. So x equals the natural log of 10. That means e raised to what power equals 10? Well, e is like 2.718. So we're going to have to use a calculator. It should be around 2. Let's find it out. The natural log of 10 into a calculator. Your calculator should have an ln button. Or you can use Desmos and type in the natural log of 10 like this. 2.3026. And just use that. Okay, well, it's going to be 2 times 2.3026. plus 5. Should be an approximate equal sign. And you can actually have just typed this whole thing into a calculator, right? 2 times ln 10 plus 5 plus 5 is going to be 9.6052. All right. And actually, if I really want to be exact, this one is an approximation, and this one is exactly equal to the thing before it, right? We're approximating in this step, but then this step is the exact same as the step below it. There we go. Last part of this video. What's the common log of 100 to the 9th power? And there's a couple ways of doing this. The boring way is just plugging it into your calculator. Ugh. We wouldn't want to do that. That'd be too boring for us, right? Well, this is asking us 10 raised to what exponent is 100 to the 9th. So you have two ways of doing this. You could expand that right-hand side out and count the zeros. However many zeros there is the answer. Or you know that every 100 is 2 zeros. We have 9 of them. That's going to be 18 zeros. Or you can write it out a different way. 100 to the 9th power. What is 100? That's 10 squared. This becomes 10 raised to what exponent? 2 times 9 is 18. When you have exponents raised to another exponent like this, we multiply those exponents. But either way, the answer should be 18 if we type it into a calculator. Good luck. Have fun. Don't fall asleep like my cats are.